Alright, problem 2. Let's do some integration. Alright, so here we're gonna use integration by parts. So what is integration by parts? For example, if you directly integrate this, you have nowhere to start. But okay, look at this. U times v's derivative is what? Is u's derivative times v plus u times v's derivative. Okay, then what if you integrate both sides? What if you integrate both sides? Okay, so this left, you differentiate first and then integrate, you get the same uv, right? And this is your right side. So you can see your right side. If this is hard to integrate, maybe this is easy to integrate, right? If this is hard to integrate, maybe this is easy to integrate, because this is given. So sometimes you can change. Alright, so that's the idea of integration by parts. In this case, let's try it. For example, this is hard to integrate but easy to differentiate. So let's just call this v. Alright, this x, it's easy to integrate or differentiate. In this case, we call it u's derivative. Then from this formula, you should notice that this should equals to u times v. Right, it equals u times v minus, right, the integration of u times v's derivative. Sorry, I literally write u. It should be half x squared times v's derivative. So this is u. This is v's derivative. Okay. So basically what I'm writing here is integration of uv equals u times v minus integration of u times v's derivative, which comes from this equation, right? But in this way, first here it's this part we don't have to integrate, so just leave it there. And this part, simplify it. Okay, you can always move the constant to the front. Half integration of x dx. Okay. And then this part is extremely easy to integrate. Minus half x squared plus c. Right. So your answer would be this. Okay, it looks like it should be minus half c, but again, c is any constant, so minus half c is also any constant, right? So just don't bother put a minus half in front. It's just plus c. Okay, so this is a trick, the integration by parts. Like part B, there's no way you can integrate straightforward, right? But you can treat it as 1 times sine inverse y integration. And so this part is your v. This part is your v. This part is your u. It's derivative, right? So it should be u times v. It should be x times, okay, in this case it's y. So it's y times sine inverse y. So it's u times v minus integration of, right, u times v's derivative. Okay, so integration of u times v's derivative. So it's this minus this. Right. So what should you do to this part? You can use substitution method, right? Because notice this part is a derivative of this part. So you can let your, let's call it, let's give it another name. Let's call it t, right? T equals y square. Or even better, t is just 1 minus y squared. And dy over dt. Sorry, dt over dy. dt over dy is negative 2y. Right, which means you're here negative y dy. So half dt is negative y dy. Okay, so it's y sine inverse y minus, okay, so it changes to plus the integration of half square root of t dt. Okay, just to try the substitution method. And this part, the integration will be positive square root of t, right, plus c. So last step, you sub y back here. Square root of 1 minus y squared plus c. Okay. Part C, it's an integration of this. Okay. So the idea is, if this part is 1, it's much easier to integrate, right? So we can treat this as your u, this as your v prime, which means your u times v. So what is v? V is this. Alright, this is your u, this is your v, minus u's derivative times v. Okay. So it's negative x e to the power of negative x plus this. Alright, so this is the answer. Okay. Part D, the integration of x times sine pi x dx. So again, if this part is 1, it's easy to integrate, right? So we treat this as your u. But here, right, it's a little bit problem. So we want this to be 1, so we treat it as u. We treat this as the v's derivative. Right. So it's going to be u times v. So which function's derivative is sine pi x? It should be negative cosine pi x times 1 over pi, right? So times 1 over pi. So this is u, this is v, minus the integration of u's derivative times v. So it's negative, right, 1 over pi x cosine pi x. here a plus 1 over pi integration of cosine pi x. Right, so for this part it's easy to integrate. Right, this part is easy to integrate. It should be sine pi x divided by pi, right? And don't forget to plus c. Okay. So part E. The integration of sine ln x. Again, you can treat it as 1 times sine ln x. Alright, so this is your u. It's derivative, right? This is your v, which should be x times sine ln x, right? Minus the integration of u times this part's derivative, which is cosine ln x times 1 over x. Right. So this is your u, this is your v, this is your u, this is your v's derivative. Okay. So it's x sine ln x minus integration of cosine ln x okay. Alright, so you can see we have to deal with this integration, and we start from here. Right, so let's use substitution. Let's use integration by parts one more time. Okay, so we stop here. Like, let's deal with this integration. All right, what is the integration of cosine ln x? So same method, you can treat it as 1 times cosine ln x dx. Okay, this is your u, this is your v. Use derivative, this is your v. So it's x, sorry. First part is u times v, right? U times v minus the integration of u times v's derivative. So v's derivative is like this. It's x cosine ln x plus, right? By the way, this is your u, this is your v, this is your u, this is your v's derivative. Okay, plus integration of sine ln x. Okay, so here's something interesting. This is some formula of sine ln x integration, right? Here, this is some formula of cosine ln x integration. So we can do the substitution now, right? Okay, so this is like the insertion. We can come back to this equation, right? So now it's x sine ln x minus, so now we know this part is this, right? So minus, okay, bracket x cosine ln x plus integration of sine ln x dx. Okay, the left side is, don't forget about the initial, it's the integration of sine ln x dx. Okay, so now it seems that we have the answer because we can move this to the left. It's 2 integration of sine ln x equals x times sine log x minus cosine log x. Okay. Well, we've made a mistake because we forgot to. Okay. Not yet. Alright. So we can get our sine log x integration equals just half x sine log x minus cosine log x, okay, plus c. Right. So let's come back to the big picture. For this question, use integration by parts twice, once here, once here. Then you get an equation, and both sides only including one unknown variable, which is the integration we want to know, and we solve it to get this. Right? So this depends on the one of the property of sine cosine, right? Because sine derivative is cosine, cosine's derivative is sine. It's kind of you repeat yourself 2 times, twice you will get the answer. Right? Okay, thank you.